Hey guys, so here are the 6.4 notes. I'm gonna run through, let's see, 1, 2, 3, 4 examples and post it, and you'll have it to view. 6.4 is due Sunday the 12th, so just keep that in mind, okay? Sunday the 12th. So example 1. We're going to identify key features. So ID key features of log functions. Identifying key features of log functions. Okay. So we have y equals log base 2 of x, and we want to figure out domain, range, x-intercept, and asymptote. Okay, so that's what we're trying to figure out. So first things first is we're going to create a table for y equals 2 to the x. So I'm going to make an xy chart. Here's y, so I'm going to do x is -2, -1, 0, 1, and 2. So y is 0.25, 0.5, 1, 2, and 4. And then since y equals log of 2x, okay, it's an ordered pair. So basically we're just switching our x and y. So we're going to do y equals log base 2 of x. So I have x, and I'm going to draw that, and I have y. So I have 0.25 for x, -2 for y, -1, 0, 1, and 2. This is going to be 0.5, 1, 2, and 4. Okay, so now we're going to graph. Okay, we're going to graph these. So I have my graph right here. Close enough. Graph right here. Here's x. Here's y. Okay, so I know I have my intercept here at 0, 1. Okay, it runs along here and then shoots up. And then I'm going to put my other one in blue. Actually, this is y equals 2 to the x. I'm going to put my other one in blue. So this is, and it crosses there. Goes that way, goes this way. This is y equals log base 2 of x. Okay. So our domain for log base 2 of x. Okay, I'm going to write it in blue again. That way we know which one it's going for. If I can get to the blue, there we go. So our domain is x is all reals with x being greater than 0 because our blue graph does not go in the negative x direction. Our range is y is all reals because I have negative y's and positive y's. My x-intercept is 0, 1. My asymptote is the y-axis. Oh, I forgot in behavior earlier. And then in behavior, EB, excuse me. So as x approaches 0, y approaches -infinity, and as x approaches infinity, y approaches infinity. Okay, so that's a very basic example. All right, Let me draw a line here and I'll do the next example for you. So we're going to graph transformations. So example 2, graphing transformations. Okay. So this is pretty much holding the exact same, okay? This is pretty much exactly the way that we've been doing it, okay? So if x gets modified, it's either going to move in the positive or negative direction. Anything outside of that is going to move in the up and down direction. So x goes left and right, y goes up and down. So just keep that in mind, okay? Just keep that in mind. So we have the graph g of x, or not graph, the function g of x equals log base 2 of x plus 3, okay? So anytime if we have f of x is x plus 3, okay? This means here, since it's in here, this would change, or no, I'm sorry, not x plus 3. It would be like 1 over x plus 3. Okay, so remember this, how this shifts it left 3? It's the same concept here. Okay, same concept here. So we have log of x plus 3. So this would be a left shift of 3 units. Okay, left shift of 3 units. All right, because this is the same thing as f of x minus negative 3. Okay, so it's a left shift of 3 units. So if, for example, I don't like that arrow. Okay, so there's my x, or y, there's my x, and y. So let's say, nope, I want blue. So let's say I have, that's my parent function, which is log base 2 of x. My transformation one is going to be moved 3 units. So 1, 2, 3. So it's going to pass through here. And this is g of x equals log base 2 of x plus 3. Okay, so it's the exact same scenario. Okay, exact same scenario. All right. Now, the last, I'm sorry, I got 2 more examples. Okay, so the second to last example is talking about inverse functions. Okay, inverse functions. So example 3. So inverse functions. Exponential and logs. Okay. Inverse functions of exponential and logs. Okay. So for example A, we have the equation f of x equals 10 to the x plus 1. Okay, so first things first, we need to write y equals 10 to the x plus 1. Okay, switch x and y, so x equals 10 to the y plus 1. Okay, to get out of the exponent, okay, to get y plus 1 out of the exponent, we need to take the log of both sides. Okay, so this is going to be log of x equals y plus 1, because log base 10 of 10 is just 1. Okay, log base 10 of 10 is just 1. So then I subtract 1, those cancel, subtract 1, and I get y equals log of x minus 1. Okay. That is my inverse of that. Okay, that is my inverse. Okay, so that is the inverse of an exponential. Okay, now we want the inverse of a log. Okay, so I have g of x equals log base 7 of x plus 5. Okay, log base 7 of x plus 5. So again, to start off, y equals log base 7 of x plus 5. Switch x and y. So x equals log base 7 of, oh, I'm sorry, I rewrote x of y plus 5. Okay, now we got to get this log 7 out. Okay, so in order to do that, we have to raise it to the 7th power. Okay, or we have to take it, I'm sorry, not to the 7th power, but this is our base. This becomes our base. So this means this is 7 to the x equals y plus 5. Okay, so whatever your base is, if that was an 8, it would have been 8 to the x. If that was 20, it would have been 20 to the x. Okay, that's what you do each time. Okay, so then you have y plus 5 equals 7 to the x. Subtract 5, and you get y equals 7 to the x minus 5. That is your inverse. Okay, that is your inverse. Okay, so keep that in mind when you're doing inverse, what was the inverse functions of exponential and logs. Okay, exponential and logs, keep that in mind. Okay, last example. So this is interpreting the inverse of a formula involving logs. Okay, so example 4. This is interpreting inverses. Okay, so it says a company uses this function to relate sales revenue. So revenue is R. Okay, so revenue R. And then it uses the cost. Okay, revenue and advertising costs. So A. So A equals advertising costs. Okay, so the formula equals R equals 12 times the log of A plus 1. So the log of A plus 1 plus 25. Okay, so we want to figure out the inverse of the formula. Okay, we want to find the inverse of the formula. So how do we do that? Okay, so the first step is we need to try and isolate. Okay, we need to try and isolate to where it's just A plus 1, or I'm sorry, not just A plus 1, but where it's just the log of A plus 1. Okay, so that's what we need to do first. Okay, so what they do is they subtract the 25 first. Subtract 25 first. So it's R minus 25 equals 12 log of A plus 1. Then they divide by 12. Okay, divide by 12. So we have R minus 25 over 12 equals the log of A plus 1. Okay, so how do we get rid of a log? Okay, how do we get rid of a log? Well, to get rid of a log, we have to raise it to whatever our base is. Okay, we got to raise each side to whatever our base is. or not raise each side to whatever our base is. We got to take our base and raise it to each side. Okay, so this would be 10 to the log of a plus 1, and this would be 10 to the r minus 25 over 12. So the log and the 10 cancel. So we have a plus 1 equals, okay, a plus 1 equals 10 to the r minus 25 over 12. Then we would subtract 1. So a in this case is 10 to the r minus 25 over 12 minus 1. Okay, that's our inverse. However, it would have been easier to use the inverse to find a when r is known. Okay, so if r would have been known, we would have done the inverse. It would have been much easier. Okay, it would have been much easier. Okay. So if you guys have any questions on this one, definitely feel free to reach out to me through Edsby, reach out to me through Remind. Let me know, and I will try and get back with you as quick as I can. Just keep in mind that this is going to be due, the 6.4 is going to be due Sunday. Okay, please make sure you're staying on top of your work. All right.